Okay. Hello, everyone. I'm John Chui from Singapore Management University, and it's my pleasure to have the chance here to talk about how to secure open source software with fuzz testing, especially from the perspective of developers or testers to discuss how to apply fuzz testing into open source software developing workflow and our experience in integrating OSS-Fuzz into open printing projects. So first of all, let me introduce the contributors for this talk. I'm John Xu. I'm currently a PhD student in computer science from Singapore Management University. My main research interest is software engineering, especially for testing and security issues on cloud-native systems. During my free time, I also participate in open source software development. For example, this talk originates from the OSS-Fuzz integration GSOC project under the Linux Foundation. So I was fortunate to be advised and cooperate with George Android Joseph, who is the security engineer at Snap, and he will give another two talks regarding OSS security after his talk. And this project is also guided by Dr. Theo Carpenter, who is the leader of Open Printing and the Linux Fellow, so with valuable domain knowledge in open printing projects. And Dr. Dongge Liu from Google, who supports the OSS-Fuzz integration from the Google side. This talk will cover the following content, which start from the basics of fuzz testing to how we have applied open source fuzzing service within the open printing project. Afterwards, I will explore advanced fuzzing methods and the future trajectories of this initiative in open printing. Let's start with OSS security. So nowadays, open source software is the backbone of nearly all digital infrastructure. In fact, a recent study found that 96% of all software systems are built using open source software. But there is a catch that 84% of these subsystems had at least one security vulnerability, which highlight the universality of the OSS bug. At the root of the modern software architecture, vulnerabilities in OSS can have widespread impact. For example, a flaw in the Linux kernel can affect every Linux server operating globally. Therefore, it is very important to secure the OSS softwares to detect these potential security flaws and mitigate them. To find these OSS vulnerabilities, there has been many testing methods available to help developers. For example, many developers may have be familiar with the continuous integration testing tools like Jenkins, GitHub Actions, or Travis CI. So these tools can help the testing automatically online whenever changes are made to the code as regression testing. And this CI testing contains the traditional testing suites, which our developers usually run locally, such as a static code analysis, unit testing, integration testing. Some may also run symbolic execution or fast testing. So it's important to note that these methods are often not end-to-end levels. So which means that developers have to write and run tests by themselves and run offline manually. So in this talk, I will focus on one of these testing methods, which is fast testing, which maybe not very familiar with developers and discuss its role in enhancing its security to open source software. So first, what is fuzzing? So fuzz testing, also known as fuzzing, is a way to check software for problems by inputting massive amounts of random data to the system in an attempt to make it crash or any expected error status. So this technique can be dated back to the 1980s. Since its inception, fuzz testing has greatly improved and expanded into different fields for both industry and academia. And today, fuzz testing tools has become crucial for discovering the vulnerabilities in software. And we can categorize fuzzers based on whether we can have access to the source code into black box fuzzing, white box fuzzing, and gray box fuzzing. So in terms of fuzzing strategies, fuzzers can also be categorized into generating-based fuzzers and mutation-based fuzzers. And the latter ones has the most popular fuzzers, for example, the AFLs, American Fuzzing Loop, Leaf Fuzzer, and the Home Fuzz, which are mutation inputs. Test cases will be guided from the coverage information of the software to achieve better testing effectiveness, which also recognized as coverage-guided fuzzing. So here's a very simple example that compared to other testing methods, fuzzing is quite simple and easy to use to find software bugs. This is an example which initiated from allocating 20,000 bytes of heap memory and accept the string name to the string concatenating. So if the incoming string is very long, then it can be trigger the heap buffer overflow. If we're going to write a unit test for the function hello, then we might preset some strings for testing, and we can see it over here, and that's it. We might miss the vulnerability by fixed test cases. Well, if we adopt fuzzing here, so we just need to replace the test case with the fuzzing input, which is theoretically infinite and is able to find the bug after a test case is longer than the preset memory of the here. So the previous demo is the simplest fuzz example, but generally the fuzzing involves a more complex process to achieve better testing result. A typical fuzzing workflow includes several key steps after writing the fuzzing harness, which targets the fuzzing input toward our testing directions. The fuzzing also includes instrumentation, which will gather the information from the test software, for example, the coverage information for better fuzzing performance. And the fuzzer needs a proper fuzz seed to mutate or generate and adopt mutation, execution, gathering its fuzz information. And afterwards, fuzzer will do the oracle checking for bugs and post-process, such as the corpus depopulation. When we are fuzzing our software, so what are we carry about? There are several evaluation metrics for fuzzers. For example, the code coverage and how many unique bugs are found, and the fuzzing efficiencies, including the true positives and the false positive ratios. So for your information, fuzzing also faces persistent research and engineering challenges. To address these issues, numerous specialized tools and techniques have been proposed. For instance, how to overcome the coverage plateau, and how to improve the fuzzing extensively for specific targets or specific domain software, and how to increase the fuzzing efficiency. In real-world practice, OSS-Fuzz from Google helps the developers to solve the problem that the developers may usually have lacking the fuzzing computing resources, as fuzzing requires continuous computing resources, unlike the unit test or integration test. Sometimes it may take months to find a deep hidden bug. And the OSS-Fuzz simplifies the fuzzing procedures, enabling fuzz as a service. If developers want to fuzz their project, they just need to construct a unit test like fuzzer harness about 100 lines of code, and that's it. And I will introduce its details. So here's the overall workflow of OSS-Fuzz, and we can see that the developers write fuzzers and merge them into the OSS-Fuzz repo. The OSS-Fuzz then will take over and send them to the cluster fuzzing service, which is also a service from Google that runs fuzzers at scale, which is responsible daily builds for the fuzzers and its cloud images. So it will continuously run fuzzers and report bugs once they are found, and the developers will be notified and have around 90 days to fix these issues till they're made public. So OSS-Fuzz is proposed in response to the famous heartbleed bugs in OpenSSL, which is a buffer overread issue caused by improper input validation. So the bug is hidden in the OpenSSL for years, while it actually will take only seconds for the proper fuzzer to detect, like libfuzzers. And it highlights the need for fuzzing infrastructures in open source software. To date, OSS-Fuzz has found around 12,000 vulnerabilities and 36,000 bugs across 1,000 projects, demonstrating its effectiveness. And it also evaluates with fuzz introspectors and the OSS-Fuzz-Gen to help improve its performance, which I will shortly introduce later. So now I will introduce our experience on how we integrate OSS-Fuzz service into open printing projects, which could be a good reference example for developers and other OSS projects. So first of all, I shall introduce the basic information of open printing. So open printing is the most popular open source printing solution, widely recognized for its reliable and consistent printing infrastructures in Linux and other Unix-like operating systems. So actually, there are 37 open printing projects for now. Around 60% of the projects are implemented in memory unsafe languages like C and C++. So there are also many testable types for open printing projects like the C structures, we can take images, PDFs, or even to the command line parameters for fuzzing. So there's a great potential in Open Printing projects for testing, and therefore we prioritize the fuzzing integration sequence and integrate 3 widely used projects for now, namely cups, lib cups, and cups filters. Before our integration, we have the through look at the Open Printing projects, and there has been some unit tests in Open Printing. Well, not comprehensively to cover all supported methods, and there is one manual written fuzz driver in cups project specifically to fuzz libipp. And there is an FL building script for libcups for offline local fuzzing test settings by the developers. So we can see that although there is a great potential in fuzzing Open Printing projects, existing fuzzing testing is far from enough. Then we choose to use OSS-Fuzz to fuzz Open Printing projects with the support of the Open Printing and Google. So the 3 integrated project has reported 35 issues with 2022 resolved bugs by 2024. So it's quite huge. And it will not be the end of the whole integration process bugs, but already demonstrate this promising result. As developers, so we may ask how exactly we integrate projects into OSS-Fuzz. So first, you should prepare a proper fuzz harness and build locally with the fuzz engine like libfuzzers. And you can create a project configuration and submit PRs to merge into the OSS-Fuzz repo. And after that, the OSS-Fuzz will do the rest of the fuzzing stuff. So specifically, how to prepare the fuzz harness. So here's a simple example of the libfuzzer harness of the Open Printing project. So we can obtain like the Unit 8 data streams as the input data and its corresponding size as the test case input. So in this harness, we'll pass the test case data to the cups filter right here to test its functionality. So such code can be built with libfuzzer settings locally for developers, while linking the libfuzzers libraries manually or built with clones with parameter like fsanitize equals fuzzer. Yeah. So after you prepared your fuzz harness, we should create a project configuration in the OSS-Fuzz repo. So it contains 3 main components. So the Docker files contain the dependencies into the building running Docker container, and the project YAML file is showing the right containing building informations and build shell script, which used to compile the harness we prepared. So to make the development more convenient, usually we will replace with a custom path in Dockerfile and maintain the build shell script in our separate maintained project, which is also adopted by the Open Printing Fuzzing. There is all the details to integrate the project into OSS-Fuzz with minimal advanced settings. So we have some suggestions for the developers when they are integrating their fuzzers. And the first is for the internal discussion for prioritized project, because it will take time to debug. And for different projects, especially in Open Printing, we have many projects. We have to prioritize the most most impactful projects to integrate first. And we can start from existing unit tests and integration tests because they are already functional, and we can just replace them with the fuzzy input, and they will save a lot of time and achieve good results. And after that, we should identify the importance of complexity of the functions with the domain knowledge, which here we brought the domain knowledge from Tails to guide us in the prioritizing the developing functions. Yeah, and after that, we can refer to the covered information for less tested functions. So actually, the hotspot and the missing testing functions can be visualized from the existing OSS-Fuzz-Gen functionalities, which I will introduce next. So as developers, after the integration, what we can see from the dashboard, while the others, I mean, not the developers, are invisible. Like we can get the project logs, potential bugs information, and once there is a bug or the potential bug are found, we can see the information like crash types and how to reproduce it. So it included the reproducing script and also the test script to reproduce. And from the fuzz introspector, actually, it's a quite advanced functionality from Google that's accompanied with OSS-Fuzz. So if we integrate a fuzz introspector into our fuzz project, then it means that we can see the high-level conclusions from our existing migrated testings and fuzzings. Oh, wait a minute, sorry. And sorry, there's an interrupt. And we can also see that there's a coverage report from the we can get it from the line levels of the coverage, after the fuzzing about 2 days or a week, then how many functions or which line has been covered or not. So there's a fuzzer overview, also including the fuzz introspectors. And we can see that the fuzz there's a visualization of the suggested functions that are not well tested for existing fuzzers. And there is a very valuable guidance for in our future development. So there are also many tricks on fuzzing OSS-Fuzz integration. So there has been not very detailed documentation seeing OSS-Fuzz documentation. Well, there are approaches that Open Printing has adopting OSS-Fuzz integration. So due to the limit of time, if you're interested, you can check our integration project or contact me directly. So there is a structure input, how to test the complex input like structures instead of just random binaries of input, and the dynamic linking, and how to design the high quality seeds. And yeah, of course, the dictionaries is also important for fuzzers, like how to mutate and how to detect bugs, including the fuzz oracles. So lastly, I'm going to introduce OSS-Fuzz-Gen, which is a new service of Google to utilize LLMs in end-to-end fuzz driver generation. So the detailed workflow are as follows. So OSS-Fuzz and the fuzz introspectors can tell which code or which suggested functions to test, and it will process with the proper prompt, which is pre-designed by the Google developers to the LLMs. So in their services, it's Gemini's, and they will respond with a fast target, and it will build and run locally. I mean, build on your cloud services. And after that, the building may crash or have different dependency errors. So they will have continuous communications with LLMs. And after that, once the fuzzer is built successfully, and it will be passed to the OS-Fuzz service, and it will continue as a running. And once there is a bug found, then it will be reported to the developers as well. So OSS-Fuzz-Gen supports multiple large language model backbones with few short prompts to enhance its performance in the fuzz driver generation. So with the help of a fuzz introspector, so it can generate the fuzz config with the following script here for developers and leverage the LLMs to generate and debug the fuzzers. So far, OSS-Fuzz-Gen has been included to more than 30,000, 1,300 benchmarks from around 300 OSS projects. So it's also very effective and very convenient for developers to use. So what do we need to set up the configurations in OSS-Fuzz-Gen to generate fuzzers for us? So there is one simple example in libcubs. Using such config, OSS-Fuzz-Gen will build and adopt multiple query loops with LLMs to generate functional fuzzers for fuzzing. So what we need exactly is just the function names and parameter types, return types, signatures. So here's an example. And yeah, we need to specify the project languages and fuzz target names, etc. So despite letting OSS-Fuzz-Gen to do with the automatic fuzz generation with a single config, as developers, usually we will query the LLMs to assist in manually constructing fuzzers. But what is the most promising approaches to let LLMs to help us in the daily fuzzing construction? Like me, I just used to chat with the LLMs and to manually get the fuzzer result. So here's a research paper I highly recommended here, which has just been accepted in the ACM 6 Alt International Symposium of Software Testing Analysis 2024. So the detailed link of the paper can be checked here. The paper constructed a benchmarking for different configurations, prompt designs, and LM backbones, and the result is very interesting. So as backbones, for example, how to design the prompt, like what we should include in the prompt designs, like we will include the task description, the library information, example code, and also if we are going to build the fuzzers, we can send them the error code to let it analyze and let the LLMs analyze the code and the errors for us, which will very fastly develop the project. For backbones, I would suggest that whatever LM resources you can use. But from the experiment, actually, so far it seems that the GPT-4 has the highest performance. So out of the request of the Google developers, I will also like to introduce the OSS-Fuzz integration bounty, which is a bonus for developers who help the OSS-Fuzz integration. So the initial integration can be rewarded like up to 5,000 US dollars, and it depends on the impact of the integration projects. And also for advanced fuzzing integration, there will be more for the bounty. Like the ideal fuzzing integration may up to 15,000. And if you merge your project into like a fast-bench integration reward, or you have detected a very impactful vulnerability, then yeah, there will also be a lot of bounties to reward this achievement. So to wrap this talk up, I would like to briefly talk about the future of open printing security analysis. So we are working on summarizing the threat models, characterized attack surfaces for open printing projects, because printing service is a fundamental functionalities for computers, and its issues in printing services are usually underestimated for now, but may have a huge impact for the countless computers. And also there are some directions like how to automatically to trace the upstream or downstream vulnerabilities, because like open printing projects like CUPS often serve as a dependencies for other softwares, which means that once there's an issue, like simple issues in CUPS may have a security impact to the downstream using like user levels applications. But we don't know about that as developers of CUPS. And certainly during the fuzzing process, we observed that some challenges have detected in detecting bugs, because if we found those potential bugs, actually they are not exploitable. And there is a huge gaps between the found bugs in the unit test like fuzzers, unit test like message level fuzzing, like lib fuzzers, to the exploitable attacks or POCs we are actually interested in as a security analysis. And also we should like know how to prioritize the fuzzers and how to mitigate the false positives of the result. So this can all be a very meaningful directions in the future development. So finally, I'd like to suggest college students that do not hesitate to contact the developers to join testing development. And I highly recommend you to join us in the open printing OSS-Fuzz and OSS-Fuzz-Gen integration or other projects. So if you have any interest in security research or other developing contribution interest in open printing, so feel free to contact me for cooperation. So that's all for my talk. And this is a project link in our OSS-Fuzz integration project. And feel free to ask questions or contact me after the conference. So thank you. Yeah, so is there any questions?
Hello. Am I audible? Can someone please confirm this? Hello. Can someone please send me a confirmation, like inside the comment section, that I'm audible and we are ready to go? Awesome. So I have received confirmation that I am audible, and shall I start the presentation? Okay, so I'll go ahead, and we have a confirmation from Jonas as well that the YouTube stream is working, so we can get started. So I'll go ahead and present my screen, and let's get started. Are we waiting for 5 minutes? Okay, awesome, awesome.
Yes. Do you hear us,
Yeah, now I
Akasha?
can hear. Yes, now I can hear you, Till. Awesome. Great.
Yeah. Now it's correct. The projecting camera must be on stage.
Just wait for another 5 minutes. So
Yes,
like,
because we have a break, and therefore the room is empty currently.
Okay, okay.
Yes.
No worries, no worries. We can
Yes.
wait. We can wait.
So,
Yeah.
so did you hear me when I so then I tell it to you again. I have seen that you are accepted into the Ubuntu Summit.
Yeah.
Your talk.
Yes, I
Did
am.
you
Yeah.
see it?
Yeah. That's
Yes,
super
yes.
awesome for me.
Congratulations.
Thank you so much, Till. Thank you so much. I'll be seeing you again in Netherlands in the October, so I'm really excited for that.
Yes, yes. We will meet again as last year.
Yeah, yeah, exactly. It's exactly a repeat of last year. Like first we had the Opportunity Open Source Conference at IIT Monday, and then we had the Ubuntu Summit in Riga, Latvia. So it's a repeat of last year, essentially.
Yes, yes. And then then we really can meet at one place and have time to chat. And so, because here,
Exactly.
even if you
Yeah,
had been there, I have to do so many things because I'm the principal organizer of this
yeah.
conference.
I
And
get it.
so
I
I'm
get it.
only running
Uh-huh.
around. I'm probably not even able to attend your whole talk. I'm
Oh,
probably
no
running
worries. No
all.
worries. Sid. Yeah, yeah. No worries.
Yes, 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 yes. You were already on location organizer for a conference, and yes, and and I think what is the most difficult of organizing a conference is organizing the AV.
Exactly. Yes. That is the main core problem. And that is where I
Because you
guess
have
last
to
time
be in
that
person
took.
there, and they let you not come some days before, or let you be together several hours on a day before the conference starts, and then it gets hectic, and so not all the people who have to know it show up, and so on.
Correct. Yeah, I get it. Yes, yes, yes. I have first-hand experience with this. Like in the last Opportunity Open Source Conference as well, it was like we did have like take a huge time to set everything up. So it was a delay of around 1 or 2 hours last time. But hopefully everything is working this time.
Yes, yes. But I think now we have it working. Perhaps we will not be able to record the workshops, or not all workshops, but at least we are now streaming the talks.
Correct. That is essential. Yeah, I get
We
it.
did not skip a talk in the beginning,
Oh, okay. Mhm.
as it happened in Monday. We have skipped the Google Summer of Code panel.
Okay. Yeah. But we did cover it up on the last day, I guess. We did cover it up on the second day, like the Google Summer of Code thing.
What?
We tried to cover up the missed session in the next day. On the next day, we tried to cover that up, the Google Summer of Code. So our conference was like 2 days, right? So on the first day, I guess we missed the conference. We missed that part where the Google Summer of Code plenary was taking in. But afterwards, we did in fact have a session on Google Summer of Code.
Yes, and now, yes, some people are coming, but I think the break is not yet over.
Okay.
Some of the participants are in another lecture. They are just 5 minutes.
Yes. We are not giving the talk. I'm simply talking with the speaker. Yes.
Akarshan, can you hear us?
Yes, Avik sir. I can hear you nice and clear.
Actually, there are two parallel. There's a workshop going on, so many people are in between something. So, like, it will take another 10 minutes for that to wrap up. So they will join soon. So it's better, like we have a better audience. So it's
Correct.
So, like,
Yes, exactly. Yeah.
we are having the conference in 3 rooms, so like it's spread out across 3 rooms. And
Yeah.
people are there in between the workshop, so they are not able to come. So let's wait for another.
And the workshop is really stuffed. I've had a short look into that room. It is stuffed.
That's awesome. That's awesome to hear.
So this is also a good sign. So we have gotten a nice workshop speaker. I do not remember what this workshop was, but what?
Something on
containerization.
Containerization. My talk title is The Quest for Supply Chain Resilience.
What?
My talk title is The Quest for Supply Chain Resilience.
And
we are talking about the other one.
Yes. Which containerization workshop?
The other one that is going on.
Because I don't remember which one this was. There were 50 sessions. But it's a good sign that people seem to like to do do the workshops with the hands-on and so on. So I see also then good chances that tomorrow people come into my workshop.
So you'll be talking about Snap, right, Till?
Yes. Today is my open printing day. We have many open printing sessions. And tomorrow is my snap. Tomorrow I will get snappy. Tomorrow I have my Snap talk and my Snap workshop.
Awesome. I'll try to attend that.
Yes, I think it's for you the first chance to get the Snap workshop.
Unless and until you'll also be hosting a Snap workshop in the Ubuntu Summit.
Yes, in Monday, I think you have not been in the Snap workshop. Probably had to do too many other things.
No, I guess I was there. I was there in the Snap workshop. We had like around 15-20 participants in the workshop as well. So it was in the bigger room that we had. at the second floor. So I was there. I was there at the Snap workshop.
Yes. What you will see new this time is the second half of the workshop, because I had only
Okay.
1 hour for the workshop in Monday.
Correct. And probably you'll also be giving a talk about the Snap workshop basically in the Ubuntu Summit as well, right? Till?
Yes, in the Ubuntu Summit, I will also give the Snap workshop, but together with other people. Perhaps we will replace 1 or 2 exercises by KDE ones, and these then Scarlett Moore will conduct. And we will have a Snapcrafters booth where I will be also. And
Great.
there
Awesome.
will be a second advanced workshop about Snap CI.
Oh, continuous
But
integration.
yes, but the other principal presenters are not me. There's another principal presenter. So we will have 2 Snap workshops and a Snap booth.
Oh, nice. We have a booth for Snap workshops as well.
What?
We have a booth as well for snapping.
Yes, for Snap we have a booth.
That's really cool. That's awesome.
Yes.
We will start off in another 5 minutes.
Yes. The room starts to fill up. And some I need help because there's a layover. No. I wanted to show the room to Akashan, but the room was, but the microphone of the laptop was not muted. I've muted it now. It's now okay. Akashan, now you can see the room. And one thing is, the laptop has, on this laptop, when you hit the left border with a mouse, there pops up a window over everything. And then I have to find out at first how to get rid of that.
The room is starting to fill up, as I can see.
What?
We can wait for the room is starting to fill up now.
Yes.
So another 3 minutes we start. Another 2 minutes.
Yes. Yes, we have around 10 people now, but we hope we get more. And we hope the workshop will end in time. Is there another workshop after that workshop?
No, it's a lunch break after that.
Yes. Which is not a good sign, because then people stay sitting in the workshop room and continue the exercises, even if the workshop is over.
Yeah, let's start.
Yes. We see here now that we have perhaps 15 people in the room. The other people are probably in the workshop room stuck with the exercises, and as there's no other workshop after that, they will stay there and try until lunch. So, but now we need the slides. Somebody could put up Akashan's slides.
Yeah, I have uploaded the slides on the conference page.
Yes, yes. Can somebody put up the slides?
Or can we share from this?
Because he has uploaded them, we.
Or like we can also share from this.
Yeah, I can try sharing from my side as well. No worries.
Yes, yes, you can also share them so that we do not need to transfer them here.
Okay, I'll try sharing here.
Now they came up. So, no, this is the wrong laptop. 1 minute, please. I must do it here. So now we can start.
Okay, so I'll get started now.
1 minute, please. 1 minute, please. So now we have Akashan, and he will give his talk about the quest for supply chain resilience. Akashan, you can start now.
Thanks a lot, Till. I'll get started. So, hello everyone. I hope you are all having a stellar time at the Opportunity Open Source Conference at IIT Kanpur. As you all can see, the topic for today's presentation is the quest for supply chain resilience. A little bit information about myself. I am Akarshan Kapoor. I am a fourth year undergraduate in the Department of Data Science at IIT Mandi. And right now I am in Germany pursuing an internship as well as a semester exchange. So that is all about me. And one more fun fact, I was one of the coordinating managers last time for the Opportunity Open Source at IIT Mandi. And here right now I'm a speaker. So it's really awesome to be back. Let's get started. Okay, the topic for the presentation was supply chain. What exactly is supply chain? Well, as can be seen on the slide, supply chain is basically the journey of a product from raw materials to the customer's hand. And along the way, we try to ensure that the right product reaches the right customer at the right time with the proper cost analysis. But how is this involved in the technical world? In the technical world, we do not have that many physical aspects. We have digital aspects. So instead of warehouses, we have servers. Instead of people managing, we have devices. So in the context of IoT, we have these devices or sensors that are recording the data. The data can then be transmitted to a backend server where the backend server interacts with the database, a backend database where it can be GraphDB, SQLite, Postgres, anything like that. And from the database, we can then visualize the application on a front-end application or a mobile application using React, Django, etc. So this was a brief summary about what supply chain is in the technical world. Now, since we are focusing upon IoT, which is basically Internet of Things, let's have a look at some of the two most important protocols in the IoT world. Okay, so the two most important protocols that we have are MQTT and LWM2M. MQTT stands for Message Queuing Telemetry Transport. To just give a brief introduction about all of these protocols, so we have everyone on the same page. MQTT works on a publisher-subscriber network. So basically, we have a publisher that is responsible for sending the data or the messages. We have a subscriber, which is a device which basically receives the data or the messages, and then we have a broker. A broker is basically a centralized instance, or you can basically say a centralized network system that helps us manage the publisher and the subscriber networks, create one-to-one connections between the publisher and the subscriber. The MQTT protocol is basically based on the TCP protocol and hence uses the transport layer security management. The transport layer security is good enough, but it can be a bit troublesome as well. I'll talk about that later. MQTT is limited to basic messaging and it lacks advanced management features. Moving on to LWM2M, LWM2M is our go-to protocol that we will be implementing in our application. So basically, it is based on a client-server protocol. There is a server, and you have many client devices. The client devices can directly poll the server for the information, and the information is exchanged. Here, we use the user datagram protocol along with the constrained application protocol. One major plus point about the LWM2M protocol is that we have built-in security features. Like, for example, in MQTT, you have TLS. So TLS relies on certificates. You might have been visiting websites wherein the certificates might have expired. So you'll have to keep updating the certificates again and again. But that is not the case with LWM2M. It has built-in encryption and authentication, so you do not need to keep on updating the certificates. Apart from that, it offers a robust full device management system, including remote configuration, monitoring, and firmware updates. Okay, we learned about LWM2M now, but how do we start implementing this protocol? Well, can we write the protocol from scratch? Do we code up the entire protocol? Since we are trying to build an open source project, we are looking for open source solutions. And hence, here comes Lation. Lation is basically a library by the Open Mobile Alliance. It is basically a lightweight M2M server and client in Java. So it basically helps us set up the LWM2M protocol. What does Lation provide? Lation provides basically a client, a server, and a bootstrap server. A bootstrap server is basically a init file. In layman terms, it is an initialization file. It sort of helps you to configure the entire server setup along with the client management. It has a support for DTLS for secure communication and hence provides for suitable scalable IoT ecosystems. The documentation is available on the Eclipse Foundation website. So you can go ahead and basically read about the LWM2M protocol and learn about how LWM2M is implemented through Lation. So this is one open source system that we're trying to include. So we had the LWM2M protocol. We found an open source system called Lation, which implements the LWM2M protocol. Now, since we're talking about IoT, one important aspect of IoT is devices. Now, to make devices work, you need an operating system, right? How is that operating system configured? Are we thinking about Ubuntu? Are we thinking about Arch? Are we thinking about Manjaro? But the thing is, these devices are very constrained. So you cannot stick to large operating systems. Hence, you'll have to scale down to a smaller operating system, or that is, more manageable in terms of memory, in terms of storage, and etc. So we need a real-time operating system that can be worked upon with small-scale devices. And here comes in Zephyr. Zephyr is a real-time operating system, and as I would like to summarize it, it's basically an ecosystem by the developers for the developers for constrained and embedded systems. So in short, to give a brief outlook about what Zephyr is, it is basically a small footprint kernel wherein you have resources for constrained and embedded systems. It does provide you with a lot of different architectures. So basically like MIPS, RISC-V, Intel, ARM, all these architectures are natively supported by Zephyr. So that's really cool. And on the other hand, it does actually provide a direct support mechanism for LWM2M server. So that's awesome. But the thing about Zephyr is this is a question directly for the audience. If you are new to Zephyr, how should you get started with Zephyr? How can you start studying about Zephyr? You might all be students in from first year to the fourth year. So these are some pretty important things that you can look up in the documentation and maybe start reading about Zephyr. So this slide is specifically for the audience. How do you get started with Zephyr? Well, you should know basics about system design and operating system. You start with learning about kernels. The first thing is to learn about what is the difference between a monolithic kernel versus a microkernel. Apart from that, you should be learning about scheduling, threading, memory management. These are basics of system design. So if you know these, it should be really easy for you to catch up with Zephyr. Apart from that, we all have learned about data structures. Zephyr uses a specialized data structure, which is called as the device tree data structure, and that is really cool in implementing all the binary files. You should learn about real-time input-output and also bus management. Zephyr has its own bus management protocol called as ZBus, which helps in managing all the binaries and all the system protocols. Apart from that, we also have pip. So pip is basically a pip. Let me correlate it with pip. It's not exactly pip. Let's correlate it with pip. Pip is basically a package manager where you can install NumPy, Matplotlib. Basically, pip installs some package, right? So Zephyr has its own package manager. That package manager is called West. So West is a package manager that allows you to scale and download all the library files related to a particular board, related to a particular device. So these are the things that you can, implement, start reading about in the documentation to help you get started with Zephyr. Awesome. So we talked about Zephyr. We talked about LWM2M protocol. And we talked about how obviously we can get started with Zephyr. But one thing that we're lacking is the complete assembly program. So we talked about LWM2M, we talked about how the Lation server is implemented through the LWM2M protocol. And apart from that, we also talked about how Zephyr RTOS is useful for managing all the devices and the connections in between. But we still are missing a database, we still are missing a front end for a complete assembly line program. So how do we get started with that? So here comes the project, which is called FlowNexus. FlowNexus is a solution, it's a comprehensive solution for small to medium scale IoT devices. You can consider it as a plug and play system. So basically, a plug and play system is basically when you have devices, these devices can directly be connected to the servers, and the servers then can automatically configure for the front end setup. So it's basically a minimal standalone open source IoT platform that you can easily connect to and get started with managing your IoT devices. Apart from that, it does simplify all the complexities of IoT deployment and thus makes it really manageable for managing businesses of all sizes. So it's basically an on-the-go setup. To tell you about more in detail about what FlowNexus generally is, FlowNexus comprises of three main components. The first, obviously, being the Lation server that implements the LWM2M protocol, a Zephyr RTOS background wherein you have n Zephyr clients that can actually connect with the server. The server is then connected to a database. The database is currently SQLite. The SQLite database is then pulled in the front end, and we have various dashboards, including the admin dashboard, the OTA dashboard or pending communications dashboard that allows all the users to go ahead and securely view all the data that is available. So it does provide you a plug and play setup. So it is an on the go setup for everyone. Awesome. I guess the slide might not be visible here, but I guess the basically the introduction of the slide is API and data flow. So obviously we'll need an API format. Right now you might be thinking, okay, FlowNexus is basically a platform that allows one-way syncing. You have Zephyr clients, you have devices, and inside the Zephyr client and devices, basically what you're trying to do is connect each of them to the LWM2M server, and the LWM2M server is directly connected to the front-end application. But that is not what basically FlowNexus is. FlowNexus allows for RESTful API management for the entire resource. So it allows you to construct format for single or composite instances. So we not only have the one-way flow, we have a bi-directional over-the-air update. Let me give you an example for this. Let's suppose you have a client. These clients are gaining temperatures. The temperatures are getting recorded in the database. Now, one more thing that is, the clients keep on running for years. So they will probably require firmware updates, right? So instead of, you can't actually go to all those devices, plug them into your laptop and manually install the firmware updates. So it'll basically require a system that allows you to upload the firmware binaries on the background server, and then it can automatically be transported back into the pipeline to the clients, so that we have bi-directional setup. On the left, here you can see, in general, we have JSON objects or XML objects for transmitting of data in web application or mobile applications. But here we had to define a single resource format or a composite resource format. Basically, what we're trying to do here is, let's suppose you have a client, a single client. That single client should have a unique ID. And when it is transmitting a resource, let's suppose humidity or temperature, it should have a resource type. So a single resource format basically comprises of the resource, the unique ID, and the resource type. Now let's suppose we scale to multiple clients. These multiple clients will have multiple unique IDs. They'll have each of the instances as multiple resource types. So that is how we compose them into objects, and those are stored into the database accordingly. So we have a proper structure. The flow is a proper structure from the endpoint to the backend and from the backend to the endpoint. So that is basically a complete bidirectional update. Awesome. So let's talk about the advantages quickly. On the right, I have tried to make a collage of what FlowNexus is basically is. FlowNexus, here you can see that this is basically your the diagram that shows the FlowNexus setup. On the right side, there's also the documentation and the front end, which is a basic screenshot of the licenses. But overall, talking about the advantages, the one most important thing about LWM2M and the entire setup about FlowNexus is that it has no external dependencies. You do not require AWS hosting. You do not require MQTT brokers. It runs locally on your machine. You simply connect everything to the devices, and once you have those devices, the devices can easily be configured with FlowNexus and the server setup. Next, it all obviously focuses on the LWM2M protocol because that is the go-to protocol for everyone. Apart from that, we provide a web application framework. It's still building. The web application framework is basically comprising of different dashboards that I told you. And we also support adding data to the backend to the database and visualizing it with the help of a web application. So it supports over-the-air updates as well. So these are like the typical advantages that you have. Another thing, we have the documentation completely configured and ready. I'll be sharing the link of that with you soon, so you can actually go ahead and look into the advantages. One important thing that I like to set up is basically how you actually can set up the entire flow. You have a Docker container file. The Docker container file can easily be configured on your laptop or your PC, and then that it can be run along to give you proper channel flow between the devices and the server. Let's suppose you do not have any physical devices. How will you work then? We also have simulations related in Zephyr where you can support N simulated clients. Instead of N physical devices, you have N simulated clients. These simulated clients, in fact, exchange data with the Listen server, which propagates back to the Django server, and then which is visualized on the front end application, which is basically the Django application. So this was about the advantages of the entire FlowNexus protocol. Apart from this, this is basically the end. I like to keep it short so you guys are not overwhelmed with all the details. But I hope you all learned something new. And if you have any questions, feel free to ask me. On the left-hand side, we have the FlowNexus documentation. You can go ahead and read about it on GitHub. And on the right side, I have my LinkedIn profile. So you go ahead and feel free to connect with me as well. And to basically, I'd like to thank everyone at the Opportunity Open Source. I'd like to thank Till, I'd like to thank Avik, and I'd like to thank all the members of the organizing team at IIT Kanpur. Thank you for the opportunity, and hopefully I'll be seeing you all soon. And if you have any more questions, feel free to ask me. I'm here. I think you're not audible, Avik. I guess the room microphone is muted or something. Yeah,
Is it okay
now
now?
I can. Yeah, it is fine now. Yep.
Great. So thanks, Krishna, for the amazing slides. And you, you were one of the primary organizers last year in IIT Mandi for Opportunity Open Source. So I just wanted you to share some. I mean, though it's a bit different from what you presented. So you started contributing for Zephyr from last year, and you landed up getting an internship opportunity in Germany this year. So if you could share with the audience how you got that opportunity and the networking that helped you in opportunity open source, so it will be grateful.
Awesome. Yeah, I'll go ahead with that. So my journey basically started like everyone starts back in India. You start with the Hacktoberfest. So I went ahead, I enrolled up for Hacktoberfest. I started looking up different GitHub repositories for the same, and I was like, okay, open source is my forte. I'll go ahead and contribute to it. So I started looking into different programs. I talked ahead with my seniors, and that is when I discovered about the open source, the Google Summer of Code program. That is how I came in touch with Avik. I came in touch with Till, and I started learning about how the Linux kernel works, how the Linux operating system works, and basically all the interior documentation aspects related to Linux. So that is how my initial Google Summer of Code work was. My Google Summer of Code work is basically on scanner drivers. So let's suppose you have a scanner system. That scanner system can independently be connected to any operating system that you have, and you do not need any drivers in between. So that was my initial GSOC work that I'm doing. I'm continuing that work this year as well. So I'm participating in back-to-back Google Summer of Code program. Apart from that, there was the internship season. So once I had Google Summer of Code under my belt, I went ahead on LinkedIn and tried to contact all the recruiters out there. So this is my profile. I have been contributing to open source systems, and that is how I managed to network. I also got to know about the opportunity open source. So I tried contacting all the speakers there. So I basically went ahead, wrote cold emails to everyone out there. Okay, I'm interested in opportunities. So if there's an opportunity, feel free to ask me for interviews, or get me started on the online assessment. So I got a reply from, luckily I got a reply from some of them. So that was awesome. And then basically the interview process started, and you had like basically the testing thing, you had interviews and all that. And that is how I ended up landing an internship here in Germany. And fun fact, I also am doing a semester exchange, so a plus point for that. But okay, so that was like the entire thing. So I'm currently working on an internship that is dealing with the flow of wastewater systems, wastewater fluid in train management systems. You can read about it. I'll probably, that's basically an application of Flow Nexus as well. Flow Nexus is basically an LWM to M server, right? Or basically a lightweight management IoT protocol. You can connect these IoT protocols to proprietary applications, and then you have a management of IoT clusters. So that is typically what my internship is about. And that's it from my side. Thank you once again. And if any one of you has any questions, feel free to like connect with me on LinkedIn, and I can guide you on that. So no worries. Any more questions?
Hello.
Yeah. Hello.
Okay. So thank you, Akarshan, and thank you all for your questions and participation. It has been a pleasure having Mr. Kapoor with us today. We are grateful for the time and knowledge you have shared with us. Let's give Mr. Kapoor another round of applause.
Thank you so much.
Thank you.
Yeah. Great. It was awesome to talk here, and hopefully I'll connect with you all soon on LinkedIn. Thank you. Thanks a lot.